Good afternoon, everybody. I'd like to go ahead and get started with today's webinar. The title of today's presentation is going to be Introduction of the new EOS Remediation Design Tool. And our presenter today is going to be Dr. Bilgin Yucu of EOS Remediation. She'll be walking us through step-by-step of the webinar, of the design tool. Before we get started, I'd like to point out a few things to the audience. First of all, those of you in the audience who are not familiar with EOS Remediation, we're a small woman-owned firm in Raleigh, North Carolina. We're actually the original developers of the emulsified oil technology for in-situ treatment of chlorinated solvents. We offer free one-on-one consultation for your project from start to finish. After this presentation today, if you feel the need that you have some questions or would like any sort of free training or more detail about our design tool or specific things related to your project, please feel free to give me a call. My contact information is there on the screen. You can find a copy of this webinar on our library, which you can access through our website, eosremediation.com. Click the login button, and if you haven't, register. And when you do that, please use your company domain email address. That will get you approved for the library access almost immediately. If you do register for our website, please check your spam box after registering, as you should get an email. And we've learned that sometimes different folks, their spam boxes or firewall filters put that email into the junk or the spam folder. So check that out post-registration. Next week, we will be at the Patel Conference in Monterey, California. We will have a booth along with several of our staff will be in attendance presenting both in platform presentations and poster presentations. So please peruse the available program. Look out for the EOS Remediation folks and go to those sessions. You can also visit us at our booth. That's going to be booth 205. We look forward to seeing you there. Our next webinar is going to be on abiotic dechlorination processes. That will be in July, and our presenter for that topic will be Pat Evans of CDM Smith. All right, so without further ado, let's get rolling on today's presentation. So Bilgin, please take it away.
Thank you so much, Brad. Hi, everybody. Again, good morning, good afternoon, or good night. Depends on your location. I am Bilgin Yucu, and today my topic is I'm going to introduce our new EOS Remediation Design Tool. First, I would like to start with a couple introduction slides. Then I am going to show you how you can run a scenario on Design Tool step by step to get you familiarized with the Design Tool. Our EOS Design Tool is specifically designed for enhanced anaerobic remediation projects using EOS Emulsified oil products and our bioplantation culture background. It is online, so you can reach the EOS Design Tool to our website, eosremediation.com. You can use different browsers. It works pretty well with most of the web browsers like Internet Explorer, Chrome, Firefox, or Safari. I should make a note here that if you have an Internet Explorer version of IE 8 or older, you could have some problems. So you should have an IE 9 or newer version in order to use the EOS Design Tool properly. It is free. It is using your site-specific data to give you the design. All the calculations and all the values that we use on Design Tool is science-based. They're based on published parameters and literature reference values. At this point, let's go back and make a brief definition of what is anaerobic remediation. So, as most of you already know, anaerobic remediation is distributing an organic substrate and nutrients into the subsurface. This organic substrate serves as an electron donor. It stimulates microbial growth. And this electron donor first consumes or consumes or reduces the oxygen, like the natural electron acceptors like oxygen, nitrates, manganese, iron, or sulfate. And then it ferments to hydrogen and acetate. This hydrogen and acetate produced is used as an electron donor to reduce contaminants like chlorinated solvents or perchlorate. So since the EOS Design Tool is specifically designed for enhanced anaerobic remediation, you should already have a preliminary screening for your site that to make sure that your site is appropriate for anaerobic remediation. You use your site data like aquifer characteristics, biogeochemical data, and we'll go over all that these one by one when I'm showing you how to use the design tool. Your contaminant concentration as your input. Also, you need to know your treatment zone dimensions, your contact time, design life, along with some safety factors. Again, I'm going to go over all these parameters one by one. And what is the output? The output will be the quantity of EOS products required for your site. EOS Emulsified oil product or the bioaugmentation culture back9. I should make a very, very important note here before we start our design. This design tool is only a general guide. Yeah, we've tested it. We're pretty happy with it. We believe it performs well, but it is not a substitute for appropriate engineering design by a qualified professional. EOS Remediation, as we are EOS Remediation, we are not a professional engineering firm, so we cannot provide you any advice on remediation system design. What we can do is we can provide you suggestions or we can give you some guidelines for the amount of emulsion required for your site. Again, I have to emphasize again, this is EOS Design Tool specifically designed for our product, for our emulsified oil product. Okay, so after this big note, let's go and start our design. Today, what I would like to do is run a statistic site on the design tool to show you how it works. We have a site A with specific characters and contaminant concentration. I'm going to run this on design tool, and I am planning to run another scenario if the time permits, but we'll see how it will go. Okay, so I'm going to use the Google Chrome for my web browser. The first thing you need to do is go to EOS Remediation website, eosremediation.com. There are two links on our website. One of them is on the homepage. As you can see, EOS Design Tool access here. You can just click here and access the design tool. Or another way is you can go to resources, to our library, and click on the link here. You have to log in before you use the design tool. In order to log in, you should have a password and a username, which means you have to register first if you already haven't registered. So when I click here, if you're not logged in, it will take you to the login page. And if you're not registered, you don't have any password, you can just click on this register and you can give your information to us and we will send you a password. As Brad pointed out, please use your company email, or if you're a student, use your school email so you can have an approval right away. So since I already have the password and username, I'll go back to the login page and I log in. It will take me to the library page, to the link. So when now I click on this, I can access the design tool. And here it is. This is our design tool. This is the homepage. Homepage is basically, or discuss the stuff that already explained to you in the slide. So I'm not going to go into details about this text. The one thing that I need to point it out is if you're only interested in our back9 bioaugmentation culture, you don't have to go through all the EOS emulsified oil design. You can just click on this tab separately and it will take you to the Deity Dosage tab immediately. I'll come back to this tab later. So for now, I'll just go back to the home page and start my emulsified oil design. Before you start the design, you have to sign this disclaimer, which basically tells we're not an engineering firm. We cannot give advice about your design. You're responsible for your own well-use and your own design. So you have to sign this, click on this little box that you agree with the disclaimer, and we'll start. The first thing is your site information. We ask you to provide your name. In this case, my name, your company, which is EOS. My phone number is 119-73-2204, and my email, which is byuntu@eosremediation.com. So, okay. On the right-hand side, you can put your site name. In this case, it is site A. Location is, I would say, somewhere. And my project number is 123. Okay. This right-hand side is for your own use. If you don't want to give any of these details, you're fine. You don't have to. But we would like to give us these information, because what will happen at the end of the design, you will submit your design summary, and one copy will be emailed to the email address that you provide here. So you can have your own copy. And another copy will be emailed to us. In order, if you have any questions, if you need some help, or if you want to go over your design with us, if you don't provide this information, there is no way that we can access your design information. So please, at least provide us this information with your design. Like I said, this is totally optional. If you don't want to give the site name, that's fine. The second step is select the type of application and product formulation. What I mean by the type of application is you have to decide if you want to go with a barrier or a source area treatment. At this point, I would like to show you our little information pages. Every time you see a green eye icon here, you can click on it and you can see more information about the parameter that you're put input. For example, in this case, it will give you definitions about what is the source area treatment and what is the barrier treatment. As much as most of you all already know, if you have like a DNAPL and very high contaminant concentrations, and it will be a better idea to use a source area treatment so EOS can be distributed throughout the treatment area. Or if you're dealing with a plume and all you need to do is just to set the plume, contain the plume, or clean that plume, you can go with a barrier design. Of course, you need to use more substrate. If you go with the source area treatment, you need less substrate with the barrier treatment, which is a permeable biobarrier configuration. If I click on this black screen, it will take me back to the design tool. So I'll go and check my parameters for site A. So it's a DNAPL site with a significantly high contaminant concentration. So I probably need to go with source area treatment with this one. So I click on the source area, and now my product. Like I said before, EOS Design Tool is only designed for our product. So we have 5 different emulsified oil products on the drop down. So you can pick whichever you want. If you need more information about the product and you don't know which product is good for your site, again, click on this little information window. It gives you detailed information about each product. And if you need more, you can click on the EOS Remediation family of products, and it will take you our website, which you can click all the products and get more information about that. For this design, I'm going back to my screen. For this design, I'm going to pick EOS Trail. Every time I pick a product, let's say EOS 450, this little window will show you the characteristics of that product, like the oil percentage, fermentable organic substrate, the electrons per kilogram of the electrons that we can supply per kilogram of the product. So I'll go with EOS Trail. It is usually refreshed by itself if you change the product from the drop-down menu, but it will be a good idea to refresh it every time you change something. Sometimes it can be slow and it cannot catch up with your changes, So every time you see a refresh or if you see some recalculate buttons later, please click on them and make sure that you have the accurate numbers. The next is the aquifer description. We need the treatment area dimensions. Again, this little icon will show you how we define the treatment area dimensions. For source area, what is X? X is the length of the treatment area parallel to the groundwater flow. Y is the width of the treatment area vertical to the groundwater flow. So, and for example, for barrier design, X is your well spacing, and Y is the width, and we also need the treatment thickness. Again, this little information page tells you what you need to use for barrier design and source area design. So for my treatment area dimensions, I'll go back to my little PDF to see what is my data. It says 200 by 200 feet area, and I have these cross-section of my side, which basically tells me my minimum depth for treatment or my contamination starts from 10 feet below ground surface, and it goes up to 30 feet below ground surface. As you can see, we don't have anything in here non-detected, but we have a lot of contamination over here. So I'll go back to my screen. My length of treatment, which is the X value, is 200. Width is 200. My minimum depth is 10 feet, and maximum depth is 30 feet. You can also work with the metric unit. You can always click on the metric, and you can just fill out your dimensions in the metric form, or you can use the feet, whatever you like. You cannot fill out the gray boxes. It allows you to change only the white boxes. The gray boxes are the calculation. So every time you put a value here, the design tool will calculate these gray boxes for you. So when you provide your minimum and maximum depth, for example, it will give you your treatment thickness, and with your treatment area dimensions, it will calculate the cross-section area. Next is the groundwater flow and site data. We start with the soil characteristics. Nominal soil type. Again, we provide you a drop-down menu that you can pick your soil type. If your soil type is something different and you don't want to use any of these, you can click the other and enter your soil type. For example, if I go back to my cross-section, as you can see, my site lithology is pretty much clay. You know, I have some silty clay here, some coarse sand, sandy clay, and so I can either go with the clay, or I can say, well, I would like to put silty clay. Total porosity. Again, I'll go back to my data. My total porosity is 0.2. I'll put it in there. And its effective porosity is 0.15. Again, if you don't know your total porosity or effective porosity, you can click on this little information page, and we provide you some literature values that you can pick your total porosity and effective porosity based on your soil type. But personally, I highly suggest go out and do your site assessment and get your own literature. The next is soil bulk density. You can do two things for soil bulk density. Either you can let design tool calculate it for us by using the porosity value that you provided, or if you know your soil bulk density, you can enter it by yourself. So this box is either a calculation or you can modify it. It's up to you. For now, I'll let the design tool calculate this for me. The next parameter is fraction of organic carbon. Fraction of organic carbon is not an available data. For example, in my case, I don't have a 2. But we can provide you a typical range, and usually this is pretty much cover most of the cases. Fraction of organic carbon is important, especially if you're doing a source area design, because it will affect your source concentration into the soil. For this case, I'll go with like a mid-range of my typical range, and I'll put 0.001 because the data is not available. You can always go back and change this number to see how it will affect your results. Next is hydraulic characteristics. Again, I'm going to put my hydraulic conductivity, which is given as 9.2 feet per day. And my hydraulic gradient, which is 0.006. And it will calculate my seepage velocity and my groundwater flow rate. One thing I need to mention here is if your seepage velocity is lower than 0.01 feet per day, it will use the minimum 0.01 as a default value. So, for example, if your hydraulic gradient is really low, for example, really low, your seepage velocity, calculated seepage velocity, will be lower than 0.01 feet per day. So the EOS Design Tool will use the suggested minimum of 0.01. I'll go back to my original hydraulic conductivity. Yeah, 0.0006. And I'll continue with my calculated contact length. Okay. Contact time is, you need to give enough contact time to the oil and contaminants to have a good contact and good reaction. So typical values for our emulsified oil product is between 60 to 180 days. But again, you can click on this information page and to see if you have like a very high sulfate loading, if you think that you're going to produce a lot of methane, or if you think you have some unknown high K layers which can cause short circuiting, you may want to go with longer at this time. So in this case, you may want to go higher than 180 days. It a little bit depends on your site. Of course, higher contact time means longer project time, and it might increase your cost. So you have to consider all that stuff. For my design, I think I'm going to go a little bit close to the higher end of the contact time of the typical range, and I'll take like 150 days because it's like a source area. We have a lot of contaminants, and we may produce a lot of methane at the end. Again, it will calculate automatically your contact length based on your contact time. At this point, if your calculated contact length is smaller than 5 feet, it will default at 5 feet minimum for the contact length. And also, if you remember, you already provide an X value, which is your length of treatment. So the EOS Design Tool will pick the greater value between these two values. If you're providing a higher value in here, it will pick this value for all the calculations, which is the case in here. So it's calculated a contact length of 55, but your length is already higher than this, so it will pick the 200 feet to go with the following calculation. Now we give the contact time, it gets the calculated contact length, it's calculated the treatment zone volume and groundwater flow. Next is the design life. Again, for a typical emulsified oil project with our product, our typical value is changing between 5 to 10 years. Again, it's a little bit depends on your own site conditions and again your cost, because higher design life could mean higher cost, or you may want to pick a design life, for example, 10 years, with keeping in mind that you may want to inject like a couple times in that 10 years. So again, it's a little bit up to your site conditions and your project. And I apologize for this. I think it's because of you're using a projector here, but you don't see it on your own computer if you're using a regular monitor or screen. I think this is because of the size of the project. So again, it gives you the design life information and tells you what you need to do with your design life and our assumptions that we're using for the calculations. So for my design life, as a typical value, I'll take 5 years from my project. And by using this design life, it will give you your estimated total groundwater volume. Next is, now we're at the biogeochemical characterization and analysis data. So next is to enter our contamination. The first section is pH and alternative. I'll go back to my data and to check what is my pH and alternative. My pH is pretty acidic, it's 4.5, and I have a very low alternative, which is 10 milligrams per liter of calcium carbonate. So when I add the pH here, well, EOS Design Tool will tell you that your pH is too low, and it may inhibit complete conversion. As you know, for anaerobic remediation, the ideal pH is between 5.5 to 8. So for our side, pH is very low. You don't have to stop the design here. It's not going to affect the amount used as the oil, but it just tells you that you may need buffer, and we ask you to call us to help you about this issue. Same with the alternative. I'll put my 10 milligram, and Design will recognize that it is very low and you may need buffer. Again, please give us a call and we can help you about the buffer requirements. Unfortunately, this Design Tool cannot calculate your buffer requirement. It is only for emulsified oil. Next is the electron acceptors and contaminant concentration. As I mentioned before, in anaerobic remediation, when you inject the substrate, some of the substrate will be used in naturally occurring electron acceptors like oxygen, nitrate, and sulfate. So we have to take the amount of these naturally occurring electron acceptors into account for in this case, I'm going to put my dissolved oxygen, nitrate, and sulfate concentration as the groundwater concentration. I am going back to my site data and see the oxygen is 1 milligram per liter, nitrate 1.3, and sulfate is 50 milligrams per liter. And I'll put this 1 as the oxygen, 1.3, and 50 for sulfate. Please make sure that you're paying attention to the unit. The groundwater concentrations are in milligrams per liter, not in micrograms per liter. Again, if you don't know the concentrations of your background electron acceptors, we provide you some typical values, and you can pick your value in the range of these values if you want. That is up to you again. When you put your concentration, Design will automatically calculate how much hydrogen, what is the stoichiometric hydrogen demand for all these compounds by using the molecular weight of the compound and the electron equivalent per mole for this compound. Next is the contaminant concentration. Again, I'll go back and check my contaminant concentration. As you can see, there is no PCE. PCE is non-detected, a good amount of PC and 6 cc, and we have no wine chloride. Those are my contaminants. So I'll go back to my design and start to pull these. So there's no PCE. I don't have to fill this out. PC is around 400 milligrams per liter, and 50 storage is 93. Yes, 93. No wine chloride and no other contaminants. If you have contaminants that we have not listed here, you can use this little these boxes to put your own contaminants. But in this case, you have to have the information about the molecular weight, with electron demand, so on, in order to give the EOS Design Tool enough data so it can calculate the stoichiometric hydrogen demand for your specific contamination. And the section C is the additional hydrogen demand and carbon molecules. In addition to the contaminants and the electron acceptors that we entered in the previous section, hydrogen that we provide by using the substrate can also be consumed by the reduction of iron oxide and the manganese oxide that may be present in the aquifer material. How you can estimate this? The one way to do this, you can go out and directly measure the amount of bioavailable iron and manganese oxides in the aquifer material. Well, unfortunately, these data are not commonly available. So Another approach could be an alternative approach is to calculate the iron and manganese demand based on the amount of dissolved iron and manganese that will be released to downgradient of the epitope. I know it's not very easy to estimate these values too, but again, we'll provide you some typical values coming from the literature and based on our own experience and published data. So you can make an educated guess for that. Again, for example, in my side, this data is not provided, so I'm going to go with some typical value, and probably I'll pick the middle one, which is 50 milligrams per liter for iron and 25 milligrams for manganese. Another, I would say, the sink for the hydrogen that will be produced is the methane. The hydrogen and acetate, which will not be used for reductive dechlorination, can produce some methane. And also, it can be released as a dissolved organic carbon. So we have to take into account all these demands additional to our contamination on the site. For example, again, this is a little bit an educated guess. Estimate amount of methane produced. I have a very high concentrations of contamination and probably need a lot of substrate. So I assume I will produce a good amount of methane, so I can go with the higher value of the typical values, which is 20. And again, I can go with the middle of the DOT value, which is 80 milligrams per liter. You can always, after you get your number as a result, you can always go back and check these numbers, or you can change these numbers, play around with that to see how it will affect your result. Okay, and at the end now we have our total hydrogen demand from background electron acceptors and contaminant concentration, and then total hydrogen demand based on to our additional, I would say, things like producing Fe, manganese, methane, and some DOT. Next is the sort phase estimate. Again, you have two options here. You can let design tools to calculate your soil concentration in the units of milligrams per kilogram by using the literature-based KOC values and by using the organic carbon content of your soil. All our default values are taken from, again, I said KOC values taken from the literature values and published data. Or if you already have the data for your soil concentration, you can enter your own soil concentration. Again, with the same idea with the groundwater concentration, it will calculate your hydrogen demand based on your soil concentration. For my case, I will let EOS Design Tool to calculate my soil concentration based on the KOC values and the FOC that I provided in the previous pages. Again, you will be able to enter your data for if we miss contamination here. And the next is the design safety factor. For all these calculations, of course, we have to do some assumptions, such as we are 100% efficient, or it's a perfect stoichiometry, and so on. In real life, none of these assumptions are really true. So we have to provide a safety factor to compensate all these assumptions. And like most of the designs, our design safety factor changes between 1 and 3, and I usually use 2 as a design safety factor, but it is up to you. If you think you're fine with your design, you can go with 1, or if you think you need a little bit more buffer, or you need to make sure that you're using enough substrate, you can go with higher than 3. Totally up to you. And let's look at the substrate requirements. Like I said, this is totally based on stoichiometry of the contamination, electron acceptors, and methane and DOT production. So you can see your stoichiometric hydrogen demand coming from all these parameters. You can see DOT release and the substrate requirements in total based on your hydrogen demand and carbon loss. If you change anything, like if you want to change your soil concentration, or if you go back and play around with some parameters that we talked, a couple minutes ago and you change them, please come back on this page, step 7, and recalculate your values. Like I said, Design Tool usually recalculates by itself, but sometimes because of some technical reasons, it might not catch your case. So it might be a good idea and do your recalculations and update the blue boxes to have accurate values. Next. Okay. Now we calculated our substrate requirements based on stoichiometric hydrogen demand. Now we have to step back and do another calculation for substrate requirements based on attachment by aquifer material or oil retention. So for effective treatment of EOS, EOS should be distributed throughout the treatment zone. However, when oil droplets migrate through the aquifer pore space, they collide with the soil surface and they stick. And eventually, the surface of the aquifer material gradually become coated with this thin layer of oil droplets that provides a long-term carbon source for reductive deformation. So it is important to consider this oil retention in the aquifer, and we have to take into account this oil retention in order to determine our substrate requirement. It's another way to calculate your substrate requirements other than using purely your hydrogen demand. In order to fill out this part, we have to determine our effective treatment thickness. What is effective treatment thickness? Effective treatment thickness is basically the thickness of your high K layers. For example, in this picture, in our little information window, we can see that our vertical extent of contamination, is around 45 feet. But if you look at the actual high K zone, which oil easily transmits through, is around 15 feet, which means your effective thickness is around 33%. If I go back to my cross-section for my site, as we determined before, our vertical extent of our contamination is around 20 feet, from 10 to 30 feet. However, if you look at this little coarse sand here, that will be the zone that oil transmits. So, and it is around 2 feet, I would say, which means my effective thickness is 10%. So I'll go back and enter this data here, which is 10%, and next is the maximum oil retention. Maximum oil retention, if you want to go with your own value, and if you want to see what is your exact number, you have to have your soil, and you have to have your product, and you have to run your own column test. I know it's usually it's not very easy to do. So what we do is we'll provide you a table based on our experience, our experiments, and some published data. So in this case, you can pick the numbers which you think is the best for your design. Oil retention is a function of number of different things. It could be the droplet size. For example, EOS Pro or most of our emulsified oil products has a droplet size around 1 micron. However, EOS 100 has a droplet size higher. So EOS 100 has a higher retention time, whereas EOS Pro's retention time is lower. Or it can be your soil. Clay retained oil more than sand, or it could be the surfactant that you're using in your own product, or several other things. So it changes with number of different things. And when I look at the table here, I can say, my effective treatment thickness is based on coarse sand, and I'm using an emulsified oil product. So I can probably go with this number is 0.0004 for my design, which is either pounds of substrate per pounds of sediment or kilogram per kilogram. Doesn't matter. The next is the design safety factor. Again, because of all these assumptions and some uncertainties in the design, we should provide the design safety factor. Typically between 1 and 2, and for coarse area treatment, we use 2, and for barrier design we use 1 typically, so I put 2, and it is calculating now my requirements based on my oil retention. The last section is my summary. So I can see my substrate requirements based on my hydrogen demand that we calculated using, contaminant concentration, oxygen nitrate concentration, and also I can see my substrate requirements based on the maximum oil retention. Now we have 2 different substrate requirements. EOS Design Tool will pick the higher one. So in this case, the hydrogen demand will dominate my design, and EOS will calculate the drums of EOS Pro I need depends on this number. So at the end, I just want to click this recalculate and make sure I'm getting the right number. The quantity of EOS Pro that I need is 55 grams. Like I said, you can always go back and play around with this maximum oil retention, or by using this previous tab, you can go back and check your product to see how much it makes a difference. Again, please make sure that you're recalculating your boxes to get an accurate value. And the next is now we completed our design and we know we need 55 drums of EOS Pro. When you click next, you see a design summary with all the information that you provided. So when you submit this design summary, like I said before, it will send you an email to the email address that you provided at the beginning of the design, and also it will send us an email so we can have your design summary. So if you have any questions, if you want to check the values with us, or if you need some help about it, we can easily access your design summary and can help you. If you have any issues with the design tool or would like to give us good or bad feedback, all of them are welcome. Please contact us. The contact information here is on the screen. You can call us, you can send us an email, and so on. I know I'm running out of time, but I just want to quickly go over the Deity Dosage, and I'm going to answer your questions after that. Unfortunately, I didn't have time to run another scenario. I was planning to run another scenario on the barrier design, but that's okay. What I can do is I can just give you quickly what is the difference between the source area versus barrier. They're pretty much the same. There's little subtle things that you need to be careful. For source area, length of treatment area is X, but for barrier, you need to use your valve spacing as the X value. In source area, total porosity is used for calculations. However, in barrier, effective porosity is used. We use the soil concentrations as a source phase estimate for source area, but source phase estimates are not included in the barrier design. Of course, in source area, you have to use more substrate, and you need less substrate for barrier design. And now I'm going to quickly go to the Deity Dosage. Like I said, if you're only interested in the bioaugmentation culture, you can always access this tab separately. It is a separate tab, so again, you have to sign the disclaimer to continue. Like the Emulsified Oil Design Tool, we again ask you to provide your site information with your name, company, and your email. This is very important. And this is optional if you want to provide some site information. And like the other one, I'm going to put my length of treatment, which is 200 feet, and my width is 300 feet. Again, minimum depth is 10 feet. 30 feet is my maximum deep, and it will calculate the treatment thickness. The same info pages are available here, and my nominal soil type was silty clay, and I'll put silty clay here. Effective porosity, I believe it was 0.16, and then it will calculate the treatment zone volume, treatment zone effective water volume, and the last section is the chlorinated consortium concentration. This is the back-9 concentration that will provide you, so you cannot change this number. This is the number that will give to the EOS Design Tool. But what you can do is you can pick your desired concentration of DHT. Its typical values between 5 times 10 to the 6 and 10 to the 7. So in this case, I'll put my Python into the big value here, and it will calculate the amount of consortium that I need in liters. If you're interested in our bioremediation culture, I suggest to go to our website on the library. 2 months ago, Brett gave a perfect webinar about the bioremediation culture, so you can have more information from there. And with this one, again, you can submit your design summary. Emails will be sent to both parties, and we'll be happy. Again, if you have any questions, any feedback, or anything like that, you can either call us, call EOS, and this is my contact information. You can always give me a call or send me an email. Well, thank you so much for your time and for your attention. I know I'm running over the time a little bit, and I apologize for that. Thanks a lot.
No worries, Bilgan. That was a fantastic presentation. Hopefully everybody attending learned something and is out there right now giving the design tool a test run for one of their sites. I appreciate everyone's attendance today. Thank you so much. We had a great turnout for today's webinar, and hopefully we'll be hearing from you and seeing some designs pour into our inboxes. And look forward to seeing everybody at Patel, and we'll be signing off, and have a great day. Thank you so much.